Good morning, good afternoon, good evening, wherever you are, and thank you for joining us for this session in the A4Q Summit Edition 2025. I am totally delighted to have with me both Adam Roman and Matthias Hamburg. Hello, both.
Hello.
Hello.
Adam's from the Polish Testing Board and Matthias from the German Testing Board. And very importantly, both are key authors for the new ISTQB Certified Tester Advanced Level Test Analyst Syllabus. I know this is going to be an absolutely fantastic session, so I'm going to get off stage ASAP. If I can just remind people to pop questions into the comments box, and we will try to get them covered and come back to you. And also, if you go to the profile for Adam and Matthias on the A4Q Summit website, you'll be able to vote for best presentation and best speakers. I'll remind you about that also later. I'm going to go away now and let you get on with your presentation. Sit back, everyone, and enjoy. I know this is really good.
Thank you, Debbie. It's my pleasure to present our ideas about what's the future of black box testing together with my friend and colleague, Adam Roman. Let me start with a short introduction. I have a PhD in mathematics in Germany and started my career as a software developer and architect in the IT industry. Then I've moved to software testing since 1997. I'm focused on software testing and specialized in test analysis, test management, test process improvement. My latest position was a managing consultant at Sogeti Germany until I retired in 2019. But I'm still an engaged member and volunteer working at the German Testing Board and our umbrella organization ISTQB. Currently, as Debbie mentioned, also working group chair and a test analyst product owner. Adam, please present yourself as well.
So my name is Adam Roman. I'm a professor of computer science. I work at the Jagiellonian University in Kraków in Poland. And my main research is on software quality engineering, software measurement, in particular software test case design techniques, which we will be talking about in this presentation.
Thank you, Adam. And this is our agenda. First, I would like to talk about who and why do they need black box testing at all, and explain you that there is a wide range of techniques around. And Adam will follow up on selecting how to select the best techniques out of this wide range and conclude our views on black box testing. So who needs black box testing? The software industry spent in fact a major effort on independent quality control. By independent, we mean independent of the developers, so someone from a different point of view. And therefore, the industry needs independent software testers who are testing on high levels of aggregation, like systems, complete systems and acceptance, and who are testing based on the specification of these systems. And these testers should be proficient in black box testing. Black box means that you're testing based on the specification and you don't consider the internal structure of your test object. There are also studies around empirical studies which confirm the need for systematic black box testing. So it's much better to do it systematically and not ad hoc, because these studies confirm that ad hoc testing will only discover a small part of the defects or bugs, and systematic testing is much more effective in this. So let's see what are the current bottlenecks of black box testing. Well, test analysis and design are mostly done manually, and manual work nowadays is really an impediment. It's a major bottleneck, especially if you aim for continuous integration, continuous delivery. And so this is why many organizations are not really proficient in black box testing systematically. Classic techniques need deterministic expected results. This is another bottleneck because you have to know in advance what are the expected results to verify the actual results. And this is nowadays less suitable for AI-based systems, which not always deliver the same results, but they still can be correct. And finally, industry or research tried to resolve these problems by model-based testing. Model-based testing means that you're creating a test model and then generating the test cases from that model. But empirical studies show a low prevalence of model-based testing. Unfortunately, I love model-based testing. However, the bottleneck is that you have to design and maintain a test model, which is usually a graphical model and needs again much effort. So industry didn't catch up on that, and this is why we have some challenges here. So let's see what is the future. We think that the future is still asking for independent quality control. It will continue to be relevant. The stakeholders need to evaluate the quality of the products independently of the developers. And since AI-based systems become ubiquitous nowadays, we need new test techniques which are suitable for AI for testing AI-based systems. On the other side, test analysis and design needs to become more automated, a highly automated part of continuous integration and design. And this automation needs a structured procedure and techniques. So we have to think about which the black box techniques are suitable for this future. And if we think that generative AI will do the job for us, we don't need to care for black box testing, then we have to be aware that AI is only practicing what it learned before. So we have to evaluate which test techniques are to be applied, even if AI does it. And we have to teach AI how to apply them correctly. So it is still very relevant to know about black box testing. Now, is there one black box test technique that fits all? The practice has shown that there is not the one test technique. There are many black box techniques discussed, and in research, they developed lots of them, and the ISTQB test analyst syllabus picks the most important ones, of which we know that they are effective under certain circumstances, in certain organizations, in certain kinds of defects, and so on. So these black box test techniques can be categorized on the test basis or test conditions they focus on. The database techniques focused on the partitioning of the data, of the input data usually. And these include domain testing, combinatorial testing, and random testing. Behavior-based techniques focus on the state-dependent behavior of your test object. These include CRUD testing, state transition testing, or scenario-based testing, and rule-based techniques focus on the state-independent rule-based behavior of the test object, like decision tables or metamorphic relations. So these are the techniques that we selected in our syllabus because they have empirical evidence of their effectiveness. But they can be combined, can be used in combination in different setups. So some of them can also be used as white box test techniques, but we are focusing now on specification-based testing. So here are the database test techniques that we selected as the most important ones. The first one, domain testing, is an old technique which has lots of evidence for its effectiveness, and it's really effective and efficient in detecting the main errors because it produces a small number of test cases but covers many types of errors. The coverage types can include simplified and reliable domain coverage, so you can leverage the thoroughness of your testing. Combinatorial testing addresses traditionally failures arising from specific combinations of parameter values. And here the challenge is that the combinatorial numbers can grow very high, and coverage types try to reduce the number of combinatorial possibilities to test by still having a high level of effectiveness, and these include base choice and pairwise coverage. Random testing has been thought to be ineffective because you just generate random inputs and run the test object, but recent studies falsified this assumption and has shown that under certain circumstances they are well suited for validating reliability of the test object. We can also differentiate here between different approaches for random testing, so it's well suited for a range of situations. Now, coming to the behavior-based test techniques, which focus on the behavior of the test object depending on its current state. We also deal with CRUD testing, which is well suited for completeness and consistency testing on a high level. It's effective in verifying the life cycle of data entities. We deal with the traditional state-based testing, which has been taught for a while now, and it's effective in verifying the stateful behaviors with various coverage types. Usually you have one switch, or sometimes if it has to be very thorough, then several switches in a row and round-trip coverage. And finally, scenario-based testing is using scenario models as the test basis, and it's effective and efficient in validating real-world workflows. Typically in end-to-end scenarios, covers the main, alternative, and exception scenarios. The third group of test techniques that we deal with are the decision table testing and metamorphic testing based on specific rules of the behavior of the test object independent of its state. Decision table testing is also one of the oldest test techniques, and it has been standardized in the meanwhile by the object management group's decision model and notation. So we can follow this model and this standard and discuss how to effectively apply decision table testing. Decision tables have also a combinatorial problem in the number of test cases or rules that they generate. So a minimization of these tables is again one challenge that a test analyst should master. And finally, metamorphic testing is a relatively recent technique with increased relevance, especially for AI-based systems or big data, where the test objects have an oracle problem and you're not predicting exactly what expected outcomes are, but you use the so-called metamorphic rule. So if you change the input in a certain way, then the output should change accordingly, and you're testing for that property. So this is the range of test techniques we deal with, and Adam, the stage is yours to discuss how to select the best test techniques and what is the future.
All right, so let's move on to the third part of our presentation. When it comes to selecting the appropriate test technique, like Blackbox test technique, for example, test analysts must understand that this depends on a number of factors that should be considered. So the first, maybe the most obvious one, is the software development lifecycle and also the part of this life cycle where we are currently in, and also it depends on the type of work products we are working with at a given stage. So, for example, if we follow agile processes and we deal with user stories, then probably scenario-based testing may be a good choice. If we deal with sequential models such as waterfall model or V model, then test analysts must remember that the role may be different in the initial phases and different in the later phases, because dynamic testing in sequential life cycles usually starts late in this process. And then the appropriate techniques must be selected. Then there is the type and criticality of the test object. So we need to perform some kind of a risk analysis, because the most critical the test object is, the more rigorous the technique should be. Most black box techniques have many corresponding coverage criteria, as Matthias showed earlier. So, for example, for state-based testing, we have zero switch coverage, or we have state coverage, or we have loop coverage, or basis path coverage, and so on. So the stronger the criterion is, the stronger the tests will be, and we will be able to detect more defects. But also we need to remember that there is some trade-off, because fulfilling the stronger criterion means we need to develop more tests, and it's more difficult, and it takes more time, and it costs more, and so on. Then we have the types of defects that can be detected by the techniques. So we need to be aware that different techniques are designed to detect some specific kinds of defects. In our syllabus, we split these black box techniques in these three main groups, so that we can focus on database techniques where the errors are data related. We can focus on behavior test techniques where defects are related to some behavioral aspect of the system. And we have this rule-based techniques where we focus on business rules or any other kind of rules that come from requirements, for example, and we can test the correctness of their implementation. There are also contractual and regulatory requirements. This is usually the case of safety critical systems. For example, in automotive industry or in aviation and that industry, there are standards that say that we should or we must use a certain technique. For example, there is this automotive standard ISO, I think it's ISO 26262. And for example, if there is a high risk for some component, then the standard tells you that you have to perform boundary value analysis or error guessing or equivalence partitioning or this kind of test techniques. And there are also project constraints. So we need to remember that not every technique can be automated in every environment. So for example, if you can't really somehow connect your test tool to the system so that you can automatically change screens when you follow, for example, state-based testing, then you can't really automate it. So it also is a factor to be considered. So the strategy for selecting test techniques must evolve. Historically, and we also know it from our experience when working in ISTQB, when we write syllabi, that when it comes to select the things that should be in the syllabus, like test techniques, for example, usually people follow some heuristics, some anecdotal evidence, they rely on their own experience. This is the same situation in everyday work. People usually follow this kind of approaches. But the future testing, if we want to have this testing really effective and efficient, it should be based on something more than just pure heuristics or some anecdotal evidences. For example, one good way to select test techniques is empirical evidence, because empirical data cannot lie, right? There's a lot of research which says that this technique is good in these circumstances, this technique is efficient or effective in this kind of context, so we can rely on empirical evidence. we should also rely on analytical methods and case studies for some real projects. And also there are some other sources of information that can be helpful in selecting the appropriate test techniques. For example, there are some international standards. One classical standard in software testing is ISO 29119 standard, which has many parts. And one of these parts, part 4, is devoted solely for test techniques. And it describes, this part of the standard describes many black box, white box, experience-based test techniques with examples, with rules how to use them. So it's a good source of information. Standard textbooks on software testing are also a good choice. If we want to follow some more scientific approach, we can also read some original scientific papers. There's a lot of research on test techniques, especially in reputable peer-reviewed journals. So we can read about many, like also new and popular nowadays techniques like metamorphic testing, for example, which is trending right now. And there's a lot of research which says that this technique is effective in this and that context. So we can also study this kind of sources. And there is tool support and cost-benefit relationship evaluation, which addresses mainly efficiency, so that we don't waste some resources and that our testing is efficient. Now, there are some techniques that may be considered less future-proof, and here we list them. So, for example, first one is equivalence, partitioning, and boundary value analysis. Maybe it's not less future-proof, but we put it in the sense here on the slide that these techniques can be replaced by domain testing, which generalizes these two techniques. Then we have classification tree method. In the older test analysis syllabus, it's considered a test technique, but actually classification tree is a model which can be used by model-based testing tools. So classification tree is a form of representation of some configuration of the system with parameters and their possible values. So if you want to use this model, then at the end, you still need to apply some concrete, like, for example, combinatorial test design technique to derive test cases from this model. So classification tree itself cannot really give you the test set, cannot really give you the set of test cases. Then there is syntax testing, which we consider more white box than black box. So we also did not include it in the new test analyst. There is cause-effect graphing technique, which is actually equivalent to decision tables. It's a more compact way of presenting a decision table, but it's an equivalent thing. And there's property-based testing, which is also trending nowadays, but it's more like the technique used by developers in a white box, low-level testing, like, for example, a component or unit testing or unit integration testing. So now, what's the future of black box testing? This approach will change considerably, especially because of the incredible growth of AI-based solutions. So we all know all this machine learning stuff, this ChatGPT, large language models. So the problem for testing is here that AI-based systems are non-deterministic. So if you, for example, ask ChatGPT about something, and suppose we want to test this ChatGPT if it works okay, right? So if you ask ChatGPT a question several times, you will get different answers. Every time you will get different answers because the language model usually is parameterized in a way that it has some form of flexibility or randomness in its answers. So you don't have one precise expected result. So the question is how to test it if we don't know the actual the concrete expected result. Then we have this whole DevOps related thing, which involves tooling and automation and CI/CD pipelines. So generative AI will automate the routine work in test analysis and design, but it won't replace testers because the testers still need to think about how to design these test cases. AI tools, as any other kind of tool, can help, but will not replace human in this process. And then the task of test analysis with this growing impact of generative AI models the role of test analysis will slightly move to, for example, prompt engineering, because there's nothing wrong in using LLMs like ChatGPT or other kind of language models in our everyday work. But to be effective and efficient in this, the tester must know how to prompt, how to construct this question to this model, right? How to prompt it to get the proper answer. So it's also something that testers, test analysts need to learn nowadays. How our new test analysis 4.0 syllabus is future-oriented. We discussed in the syllabus a selection of systematic and up-to-date black box test techniques based on our research, not only heuristics and anecdotal evidences. The focus was here on effectiveness and efficiency. So we selected techniques that really can be useful for testers, that really can make a difference in our testing process. This selection of techniques, as I said, is grounded in strong empirical evidence. So we didn't just, thought about, oh, maybe this technique is sounds good, so let's include it. No, we did a thorough research to select to carefully select the group of test techniques that are worth mentioning. And the syllabus links the needs of practitioners with the results of research. So we somehow bring academia and practitioners together. And black box test techniques are not the only topic in our syllabus. So this last slide summarizes the content of, more or less, the content of our new test analysis syllabus. So we have this classic test techniques like domain testing or crowd testing that Matthias mentioned before. But we also focused on these challenges related to AI-based systems. So, for example, there is a so-called oracle problem in software testing, which is strongly related to this kind of systems. So we discuss how to handle test oracles, which black box techniques are useful for solving this issue, like metamorphic testing, or discuss the random testing as well. There is also nowadays this need for automated testing in CI/CD pipelines, which we also discussed. So here in this context, we discuss risk-based regression testing, automated test design, or keyword-driven testing or keyword-driven scripting. And also there's the whole chapter about defect prevention strategies, such as defect prevention or supporting phase containment or mitigating the recurrence of defects, which is also a part of responsibility for a test analyst. So that's all. Thank you for your attending. And now, if there are any questions, we will be happy to answer them.
Well, thank you both so much for that. I know we have got some questions, so let's get straight into them. Can black box testing be automated, for example, by AI tools? And if so, will testers still be needed for designing test cases?
All right. So, of course, when we talk about automation, usually people think about automating test execution, which means to automatically run the test cases. Automating test design is something else, something different, but it's also there. There is such thing as automating test design. And actually, our syllabus discusses also this topic. There's a section about the whole section about this issue. So there is a lot of tools that allow you to do this, usually in the context of model-based testing that Matthias mentioned before. So the tools work in a way that they are able to produce in an automatic manner test cases. The tool designs test cases, but we cannot replace human. We cannot replace tester here, because at the beginning, even if we have this tool, the tester must provide the model of the software. to this tool. And this is the most intellectual part of this process. You cannot really fully automate this kind of activity. So it's because it's difficult. It depends on many things that you can't really put in prompt, and the ChatGPT won't give you this precise model. So we also discussed the issues about modeling in testing in our syllabus. And then once you have this model, the thing is really simple, because model-based testing tool just reads the model, processes it, and gives you just the. You can ask it. You can ask the tool to provide test cases that fulfill some kind of coverage criterion, or to produce the test cases in some manner, like randomly or with some other probability distribution or whatever, and then the tool will automatically do the task for you. But still, a good news for all of us is that we won't be replaced by fully replaced by machines.
Thank you. Matthias, is there anything you wanted to add there?
I just wanted to add, I agree with everything Adam said. I just wanted to add that the role of the test analyst will shift to the prompt engineer. So you have to train the artificial intelligence to do it right. It won't be able to do it from the beginning. Like a little child, you have to train it how to walk, how to act. And this is the same for artificial intelligence.
Thank you. Let's have another question. Why are we replacing equivalence partitioning and boundary value analysis with domain testing? What are the benefits?
So the shortest answer is that domain testing is like a general form of these techniques. And in practice, because when you have some experience with ISTQB and exams, these certified tester exams, when you have questions about equivalence partitioning or boundary value analysis, the questions are really simple. They deal with some very simple settings. Like, for example, you have a domain like numbers from 1 to 10, and you split it into 3 groups, and these are equivalence partitions or whatever. But in practice, in real life, testers deal with much more complicated domains, not one-dimensional, but highly dimensional. And these are not only some simple numbers. The domains may be really very complex, and the elements of the domains may be not numbers or letters or simple objects, but very complicated things. And then the question is how when you have like 7 variables and each of them is very complicated, and also you have some relations between them. For example, if you have body mass index, right, and you want to test this website for calculating body mass index, you have 2 parameters, height and weight. But to calculate this BMI, you need to put into the formula these 2 things, so there are some relations between them. So you need to also take these relations into account. And this is something that simple equivalence partitioning or simple boundary value analysis cannot do. So that's the simplest answer. It's just a generalization of these 2 techniques.
Matthias?
Yes, I'd like to add that the basics of equivalence partitioning and boundary value analysis are not obsolete. So they are integrated in domain analysis. So you still have to subdivide the input domain into equivalence partitions and to care for the boundaries, because the truth is still valid that the most defects are at the boundaries. Yes, so they cluster at the boundaries, so to say. And but indeed, domain analysis is much more flexible, and you can apply it for much more cases.
Thank you. Time for one last question. I already have an advanced test analyst certificate from 2012. Or actually, I guess even more recent than 2012. Do I need to take the exam again, anew?
Yeah, let me respond to that one. Formally, you don't need to. So the grandfathering rules of ISTQB say that test analyst certificate is valid only for unlimited time, lifelong. However, this is only the formal side, and if you want to keep up with the progress of our subject domain, then I would recommend to follow up what happens, maybe attend some refreshing seminars or study yourself. And it's a good idea to retake the certificate if you want to ensure or get a confirmation that you're up to date.
Thank you so much. Thank you both, Matthias and Adam. Really enjoyable session and some useful information insight there. A reminder to everybody to go to your profile on the A4Q Summit website and to cast their votes. And again, thank you to you both and thank you to the audience. And I'll just finish by saying stay tuned, everyone.
Thank you.
Goodbye.
Goodbye.